Hello and welcome to an introduction to the I2B2 Health Outcome Monitoring and Evaluation, or home cell. My name is Bill Adams. I'm the Director for Clinical Research Informatics here at the BU CTSI, or Clinical and Translational Sciences Institute. And today I wanted to give you a brief overview of a new software component that we've developed for I2B2 to help researchers and quality measurement professionals to measure health outcomes using I2B2. In a previous talk, I've described more about I2B2, and there's much more information available at i2b2.org. But when we started this project, we realized that while I2B2 excelled at cohort identification and was a very powerful data tool, it lacked really important functionality to describe clinical processes and outcomes over time. So in order to be able to use this resource that we developed here at BU, we needed to begin to think about new functionality to help us do that. And we hypothesized and have shown that outcomes research is quite possible with the addition of some new ontologies to I2B2, to the actual loading and processing of new data, and finally, and most importantly, a framework and some software for actual modeling temporal relationships between facts as exposures and outcomes. The health outcome monitoring and evaluation team is shown here. It's myself, Nancy Crescent from the Health Disparities Unit at Boston University and Boston Medical Center, Shibi Thomas, the director of our clinical data warehouse here at BMC, Sarah Thomas, the software developer for the majority of the home cell, and Christopher Shanahan and Michael Pash-Orlau, both internal medicine researchers here. This project was supported by the National Heart, Lung, and Blood Institute through an RC2, or Grand Opportunity Grant. Again, I've talked more about I2B2 in the previous talk, but the new ontologies that we added to create a new type of data repository based on I2B2 are shown here. The repository that we built, we called the Massachusetts Health Disparities Repository because our primary goals were to actually assess health disparities and health equity within the city of Boston, and that was the primary impetus for the grant. And in order for this MHDR to allow us to do this type of assessments, we needed to create some new ontologies. And the new ontologies that we created were clinical services, knowing that a patient was a primary care patient or was seen in a specialty area. For that, we had to create a custom ontology. An insurance ontology, where we could actually map the insurance that a patient had at the time of a visit. And we initially did use the University Health System Consortium framework, but ultimately changed it to a custom coding system to better represent underinsurance and uninsurance within patients in inner city Boston. And we also created a new clinical ontology to allow us to map vital signs like blood pressure and height and weight to standardized SNOMED codes. And these new ontologies look something like this. Within this health outcome monitoring system, we're able to look at ER visits, inpatient visits, and outpatient services are organized within a construct that lets you look at the actual type of visit that occurred. We also allow users of this new ontology to look at services by department, which is shown here, but also within each center that's participating in our project. So our database is a multi-centered combined database, and we're able to look at services here. This is important because in pretty much all of our health outcomes, we're interested in studying a population of patients who are primary care patients, and without this type of ontology, it's very hard to identify those patients. We're also very interested in cardiovascular health outcomes. And so spending the time to actually map vital signs was also very important. And we now have a blood pressure ontology and some but other vital sign ontologies as well, all mapped to standard SNOMED code, so others could use the same ontology. We also mapped addresses to GIS codes, both census tract and zip code, of residents at the time of the visit using our registration system and some GIS software. So we're able to know where people live at particular times and begin to understand health outcomes by neighborhood and location of residence. For insurance, as I said earlier, we did actually have to come up with our own ontology so that we could better understand the different types of insurances that people have at different points in time. And finally, we also spent a lot of time developing a substance use ontology related to cigarette exposure. So we've mapped over 16,000 free text values in our clinical databases to a pretty simple ontology of 7 concepts: passive smoking, ever or no, exposure, current smoking, yes, no, unknown, and then whether or not the person has ever smoked in the past. And this is useful because you can begin to measure quit rates by looking at people who used to smoke but no longer smoke and things like that. So moving on to the actual home cell itself, with that new ontology and a series of research questions that we had, mostly related to trying to study the health outcomes related to health insurance reform in Massachusetts, we took on what we call a grand challenge, which was to create a new I2B2 health outcome monitoring and evaluation cell to model and assess a wide variety of relationships between essentially any fact as an exposure in I2B2, any other fact as an outcome, or some combination of facts, modeling many relationships related to time, how things occur in time clinically. And then we also really wanted to be able to stratify all these health outcomes by subpopulations within the database. To understand health disparities, we needed to understand how these health outcomes were different for one group versus another. And finally, with any outcome measurement, it needs to be interpreted in the context of time. And so we needed to be able to apply these these criteria up above to discrete reference intervals. For example, a month in time to look at monthly outcomes, and years, and perhaps even longer periods of time as well. And again, I've talked about I2B2 in my other talk, but basically I2B2 is best thought of as a collection of cells, and these cells can work together in a plug and play type of framework. In aggregate, these cells are called the I2B2 hive, and what we were doing in this project is to develop a new cell, the health outcome monitoring, or home cell, to be plugged into what we already had. And in our install here, we have a project management cell, but mostly we use the ontology cell and the CRC, or the clinical repository cell, data repository. So as we set out to create the home cell, we really came up with a pretty simple model of how to think about a wide variety of health outcomes using I2B2. And the final home cell design leverages this idea of a baseline query, where we use an existing I2B2 query cell query to define the baseline population of patients to include in the subsequent analyses. And what this does is let us pull off a subset of patients that's much smaller than the over 1 million patients that are in the database right now. And by reusing this existing I2B2 query cell query, we can add on to that a series of constraints. And after about 6 months of work, we came up with really 3 essential constraints that could be used to model this temporal health outcome relationships. One we call the occurrence constraint, which is one fact that occurs within a certain amount of time of another fact. For example, hospital readmission rates would be an inpatient fact followed by another inpatient fact by less than 30 days, would be a 30-day readmission rate. A value constraint takes the value of a fact, like hemoglobin A1C, and allows you to specify um, whether to include patients with a value greater than this for people who are out of control, or less than something else for patients who are in control, and conditionally also relate that value to a point in time, like a visit or a reference interval or something like that. The other thing we needed to add was an age constraint, where users can model the subject's age at the time of the fact. I2B2 is good at identifying patients who are a certain age now, but it's not so good at identifying patients who were a certain age at a particular observation or fact. Finally, because this project was really focused on identifying health disparities and different health outcomes in different groups, we wanted to be able to stratify that outcome by any type of subsets or patient subpopulations within I2B2. And so how we do that is we reuse, again, existing I2B2 queries that can stratify the health outcome for different populations. So for example, by doing a query of all African American males or white females, we can identify subgroups, and then we can cross the health outcome that's being measured with those subgroups to look at the health outcome within those subgroups. And I'll show you how we do that in a second. And finally, the other really important concept is this idea of a reference interval. Because all health outcomes occur over time, we wanted to be able to let users look at the health outcome during a month, during a year, or during an entire period of time, so that differences over time could be easily seen and visualized. And again, I'll show you that in a second. And what the constraints look like within the software are shown here. So an occurrence constraint lets users drag and drop concepts over from the ontologies and drop them into each of these concept boxes, and then say whether the relationship is about preceding, following, or could occur independently, like right here. And then equally important, those concepts, one or both, none, one, either, or both, or none, can be required to be in relationship to the reference interval, which is specified later, but is usually a month or a year. So this is an occurrence constraint, gives users this range of options to choose. And for value constraints, since they're generally numeric values, users can say that they want to use the average, the minimum, the maximum, the most recent value. They can drag and drop a numeric or actually a text-based variable over here. And then they can say that that value has to occur before, after, same thing as over here, to some other concept optionally within a certain number of days. And finally, they can set the value for that. And in this way, you can define populations of people based on the value of lab tests or answers to particular questions that actually use the value of the fact rather than just the presence of the fact. And finally, it's pretty easy to pull over any fact in I2B2 and say that that fact had to occur within a certain age range or less than a certain number of days or years of age. And then that can also be applied to the reference interval. Just a quick note of how our I2B2 install at BU works. In my previous talk, I talked more about the web client and I2B2 more generally. This is a web-based system that users can use to come in and do aggregate queries without additional IRB approval. The repository itself has been approved by the IRB, and since only aggregate queries can be done, the queries themselves, the aggregate queries, are not considered human subjects research and don't require additional approval. BU I2B2, which is this thing that I just described, only includes data from Boston Medical Center. The MHDR, which is the system where we have the home cell available, is actually a much bigger system. It includes data from 8 community health centers as well as Boston Medical Center. It allows users to pull out patient level data for research. Every protocol needs its own IRB research approval, and researchers use it through a dedicated research workspace. The software is also different. It's not a web client piece of software. It's actually Java code within an Eclipse-based workbench, which is the other way that I2B2 can be used. So this home cell that I'm about to describe is only really available at BU to researchers who have specific projects and that are being done kind of in collaboration with the MHDR team, whereas the web client is more generally accessible but does not provide access to the home cell. And then a little bit about the data within the MHDR. We pull in data from administrative databases at each site that participates in our projects. We also pull in data from one of our largest health insurance companies in Boston. And then we also pull in as much granular data as we can get from any of the EHRs. And right now it's pretty much all granular data but not text data, and not radiology results or pathology results. And that granular data we pull into this area we call the staging area. This is basically all EHR data, this is administrative data, and this is payer data, into the staging area where we link it to a master patient index so that all data for an individual is linked across the continuum. We clean up the data a little bit, and then we link all the data to standardized codes. Probably the best known code is ICD-9, but we also use lab codes and medication codes. And in the end, we push that data out in a de-identified format into I2B2 to be made available to researchers through the MHDR. And the final database is actually quite simple. It's just one table of people, currently with about 1.4 million people, one table of facts about those people, currently with almost 700 million facts for those 1 million patients, and then a library of concepts that tell us more about the facts and make it possible to navigate through the fact hierarchies. The way that researchers would generally use this is either through the query cell tool itself, or the home cell, which I'll be showing you in just a second, or through data extracts, which aren't shown here. And again, all this data is de-identified. The way we de-identify the data is by altering all dates for an individual by